So now let's look at vias. When I was doing the section on what happens when signals get fast, I showed you that because of loss in the path, the vias just really weren't visible. The reflections off those vias were attenuated by the time we got to the receiver. When nets are short, that loss is small, and we can't expect the effect of vias to not be noticed. And you could look at the vias as two little capacitors hanging down from a section transmission line, and that looks like a pi filter. And what we're going to see in a minute, that's what it looks like in terms of attenuation. So again, we talked about 100 mil thick board with 10 mil via is about 0.3 picofarads, and the 30 mil is about 0.6. So I'm going to show you an example, and this is my test board that I had up earlier. When the path is short and there isn't something to attenuate the reflections off those two vias, we wind up with the pi filter. This I'm going to show you is two 8-inch long transmission lines, where one of them is near the top of the board, where signal has not traveled the length of the via, and the other is near the bottom where it has. And that's this picture right here, where the top one is I've traveled the length of the via, and this one I haven't. So what's going on is when you travel the length of a via, and this is one of the secrets of how to keep the vias from causing problems, that capacitance is distributed along the length of the via, which is a transmission line. That's what's happening. And when we don't go the whole length of it, we get this because those two capacitors hanging down. If you look at that's an 8-inch trace, and you can see that at 6 gigahertz, we've got 30 dB of attenuation. So that is PCI Express Gen 4. Look at the attenuation at that frequency. And so there is a paper, I think I've cited at the very end of this. It's called Short May Not Be Better, and it is was done at DesignCon. I forgot what year, but it was by IBM, who had made a server with a bunch of 10 gig signals on it. And they agonized over all the long traces, making sure they wouldn't fail from loss, and none of them failed. Only the short ones failed. And what is going on here? This is what's going on.